Welcome. In this video I talk about control structures. Rust has all the usual control structures plus pattern matching, and I shall go through some examples. We begin with the if statement. To have something to if about, I have created a list of command line arguments as a vector, so we can modify at runtime what is going on here. I just use a simple condition about the length of the argument list. And as you can see, the condition of the if is written without brackets, and the two arms of the if are always written with curly brackets. Obviously, the else is optional, and we shall see how this works. Note that I'm using if here as a statement. Here it says there's no argument because I haven't given a command line argument. If I give one command line argument, it says first argument 1. If I give two command line arguments, it just looks at the first one. Nothing unexpected so far. However, the if statement is a bit more versatile than in C++. In this example, I'm using the if statement as an expression. So I assign to the value, to the variable s, the result of this expression here. Now, I'm writing the if as before, but I leave out the semicolons in each arm. That means the if statement, the if expression here, returns as value either the expression in the first arm here, this is the last expression executed in this block here, or if the else part is executed, then it returns the last evaluated expression here, that is this one here. So s is of type string in this case, and either I return a copy of the first command line argument or a newly formed string like this. Notice, of course, that the two arms must return the same type, otherwise I get some type compiler error. And in this case, I can just write the result, so the outcome should be the same as before. So there's no argument, and here first argument is 1. Notice that this means that the if statement plays not only the role of the if statement in C++, but also the role of the ternary operator, because I can have the if expression here and have two different expressions here, but it's even more versatile because I can put multiple statements in each arm and just have the expression evaluate to the last expression in the block. There's one more thing about the if statement. What happens quite often is that I have result values like this x here. I try to convert a command line argument to a number, int 64. And notice that the result is a template type, so it's either a result with a proper result or it's a result with an error. To distinguish this case, I have to do an if statement. So I ask myself whether it's an OK value here. And here we have again the destructuring or pattern matching syntax. So if we use if let, then I can use pattern matching here, and I can extract the actual numeric value here so that this identifier y is bound to an actual integer in case this result here ends up to be OK of something. Else would be the case that it is an error. And in that case, I can just write out the argument as I want, or alternatively, I could access this x value or whatever. Let me see how this runs. If I give no arguments, nothing happens. If I give numeric arguments, it says found number. If I give non-numeric arguments, it says no number. So it works as expected. So the if let can bind a new identifier by means of pattern matching, as we have seen before. That is extremely convenient for certain cases. Next is loops. There's a loop statement, which is just an infinite loop. And obviously what we need a way to leave the loop, that's the break statement. That's nothing unexpected, except that there's a possibility to break out multiple loops in one go. That means if this loop statement gets a label annotation here with the apostrophe, then I can use a break statement in the nested loop to actually break out of both loops. Yeah? The logic here doesn't really matter. I'm searching in some silly way to solve a concurrence, but just look at the loop structure here. Let me run this. So indeed, I've solved the problem. And once the solution was found, I break out here and I use the if statement here to terminate the inner loop to move to the next step in the outer loop. Of course, an endless loop statement with breaks is not always what we need. So let's look at while statements. Nothing very unexpected. The while condition is here written without brackets in comparison to C++. Other than that, it behaves exactly as expected, except that we also have the multiple break thing here with a label annotation for a while loop. And other than that, it's exactly as it would be in C++. Let's run this. It works exactly in the same way. There's of course also continue, and that works exactly as expected. We move on to the for statement, which is usually used to iterate over collections, as we'll see in more examples. Fortunately, there's also a special collection named arrange. So this here is Rust's way to run through a range of numbers. For example, here from 0 to 4, and here from 0 to 2, again the same notation as for slices. If it is dot dot equals, that the upper bound is included as well. Likewise, we have a label possibility and a break statement or continue statement to be able to move or break out of inner loops and outside the outer loop as well. So this is the same program as before. It runs as before, just using a for loop. To illustrate this point, I've made a silly example here. I again have the vector of strings, which is the command line arguments. Then I show you how to iterate over this argument list. Notice that I have here this notation for a in a reference to the vector. This means that a will be a reference to a string in here, immutable reference. Or here's another example, a for a string. Dot chars gives me an iterator over the characters of the string. Notice these are Unicode characters. So this iterates over the Unicode characters, and I can do things with that. Here I illustrate again break and continue. So here, if there is an X character in a command line argument, then I terminate the whole program. And if there's a Y letter, I continue the program and move to the next command line argument. So let's see how this works. If I put 1, 2, 3 here, I get a very long first argument with the name of the program. And then the other arguments, if I replace the second argument with an X, it terminates after that one. And if I put a Y here and further letters here, I just see the Y. I'm including the match statement in this video because it's a control structure similar to switch in C++. For scalar values, not for strings, but for scalar values, you can use the match statement just by matching on a value. This value has type of an integer here. And I can just give the different arms like this here. So I can give single values, or I can give multiple values, or I can give the underscore for an else part. So in this way, the match statement is essentially the same as the switch statement for scalar values. Let me run this. So it says a 1, either a 2 or a 3, or indeed a 4. Notice that I have used the match statement here as a match statement. Similar to if, there's the possibility to use match as an expression. So in that case, I must use arms here, which don't have a semicolon at the end. That is, these blocks here, or single statements, need to return the same type, all of them. And then I could assign the result of the match expression, and it would be the result of the corresponding arm which is executed, and the last expression in there. We have now covered the control structures, the usual control structures of Rust. For the matching case, I have here just covered scalar cases, but we have seen other matches for algebraic data types before, and I will probably do a different video just about matching and all its intricacies later in this series. For now, this is it for this video. Thanks for watching. I hope you enjoyed it.